Hello guys, this is going to be a little look at 7D. Now 7D is a little bit different because for 7D, we're looking at like an n times n sized matrix. So an n times n matrix is where my rows and my columns are going to be the same size. And this can be, you know, a 10 by 10 to a 50 by 50 to a 3 by 3. So we spoke about this idea in year 11 where I said, hey, for my identity matrix, no matter how big my identity matrix is, I always can put ones on my leading diagonals and the rest can become zeros. A good thing to mention, my identity matrix is a square matrix, which is like an n by n matrix. In other words, my rows match my columns and it kind of forms a nice little square shape. In terms of the actual questions for this, it's actually going to be looking at the calculator skills. So let's just look at example 9 and example 10 first. Example 9 here is about using your calculator to find the inverse of a matrix. So to do this on my graphics calculator, I want to access the matrix template, which if I click this button here, it gives me all my different templates. If I click the 3 by 3 matrix here, then I can select my rows and my columns. So this question was a 3 by 3, so I'm happy for it to be a 3 by 3. So now I just want to put my numbers in. I have 3. If I click tab, it lets me move through the different element slots nice and easily. And if I keep tabbing my way around the matrix, I can fill it in like so. So once I've got my matrix filled in, if I want to find the inverse, I can simply just click on my little hat button here, which lets me do in any kind of powers. I can put in the indice of -1. That will now give me the inverse of this matrix. Now, bear in mind, I can look for common factors and I can bring scalar quantities out the front. But for this, the textbook was happy to leave our answer like so. So a good thing to note as well, let's say I want to use this matrix in a bunch of stuff, get rid of my power of 1. I can also click Control VAR to store this as a letter. Let's say I want to store it as A. Now, if I ever do, it always defaults to lowercase, apologies. Now I can just simply do A to the -1 and I can achieve the same thing. Just notice when I click A, it's in bold. That's because it's a variable. If I wanted to recall that, I could also click this VAR button. I would see that I have variable A here. And if I click enter, you can see A is just matrix A, which I put in all the way back here. That's a little trick to help you. If you're using the same matrix a lot, this can be a way to do it. Or you can simply use my keypad to toggle up to my previous matrix, click enter, and I can insert it that way as well. So that's the calculator skill for the first example. For the second example, it's going to be using the calculator to find the determinant of a couple 3 by 3 matrices. I'm just going to use the same matrix I did last time because the skill is exactly the same. So if I come back here to my original matrix that I've got written out, I can simply just write DET. I can put this whole thing in brackets like so. And if I click my enter key, I will now get my determinant of my 3 by 3 matrix. I could also write DET and I could do brackets. I could use my letter A because I've stored A as this matrix. If I click enter, it's going to be the exact same thing. I can find this in menu under matrices and vectors. And I can simply just click the determinant button here and it gives me my determinant. So if I come back to the textbook, this is what 7D is all about. It's about understanding my identity matrix is ones on the leading diagonal. And it's just reminding ourselves of our calculator skills. For example 8, I have matrix A, which is a 3 by 3, matrix B, which is a 3 by 3. The first part of the question asks us to find the product of A times B. To do that, I multiply my row by my column, row by my column, row by my column, and I keep doing that again. I just do it more times because I have a 3 by 3 instead of a 2 by 2. If I do that, I find my answer is my identity matrix. So if my answer is my identity matrix, the only way I can get my identity matrix is by multiplying by my inverse. So if I do A times B and I get my identity matrix, then B has to be the inverse of A, or A has to be the inverse of B. In this question, it says, hence find the inverse of A. So therefore, the inverse of A must be equal to B because I got my identity. Remember, I get my identity matrix by multiplying a matrix by its inverse.